Greetings, Yuma High School. Welcome to your first foray into flipped lessons. I hope this works for you. We are going to go through using formulas to find segment midpoints and distances in a coordinate plane. Okay, we're pulling this out of Pearson Text Section 1.7, and we're going to get into coordinate planes, midpoints, distances, and our key concept will be the two formulas, midpoint and distance formula, that we will get to a little bit later. All right, so your task is to take good notes, just as if this were a class. You feel free to hit the pause button on the video anytime you need more time to absorb something. There will be points during this exercise where I will give you some problems to work on, and at that point, again, hit the pause button, work on them, and then when you hit unpause, when you hit play again, I'll reveal the answers and you can check along with you, but I'll let you know when that's going to happen. I may go a little bit quick. I need to try and keep this down around 15 minutes or so it doesn't get too long. So here we go. First, a little review. We've already learned how to find distance between 2 points on a number line. Remember that formula we've been playing with where distance is the absolute value of the difference between the 2 points. So looking here at points A and B, this particular segment has endpoints A at -6, B at 7. So plugging that into our formula here, the length is -6 minus 7, or the absolute value of -13, or the positive value, 13 units. Now notice it doesn't matter which point we take first. Since we're taking the absolute value, as long as we take the difference, it's always going to work out. If we consider B first, the 7, and then we do subtracting 6, we end up with the absolute value of 7 minus -6, which is positive 13, 13 units, just like before. All right, so here's a little practice on your own if you'd like. If you already feel comfortable because we've been doing it, that's okay too, but if you want to practice along, now's the time to hit pause, and when you hit resume, I'll reveal the answers. So here are the answers. I hope you got them all right. Now on to the new stuff. Midpoints. All right, we talked earlier, I know we defined this earlier, but a midpoint is a point that divides a segment into two congruent segments. In this case, in this diagram, M, since it takes AB and splits it in half, splits it into two congruent segments. I just messed up my little sign there. M is the midpoint of segment AB. So now if we think about AB having coordinates like on a number line, here's the formula that we're going to use. The midpoint M is simply the average or the mean of the coordinates of the two endpoints. And here's our formula. Like any average or any mean, we add up the values and divide by 2. So on this particular line, AB from before, remembering that formula, we're going to take the two values for the endpoints, -6 and 7, add them together and divide by 2, and we find that the midpoint is equal to 1/2. Right here would be midpoint M. And that makes sense, right? There's 6.5 units from here to here, and 6.5 units from here to here. So we've split it into two congruent 6.5 unit segments. All right, so simply take the average of the midpoint, or average of the two endpoints, and you have the midpoint. Again, a few more to practice on your own. This time I would advise you do it since you haven't used this skill before. Hit pause, and when you're ready to resume, I'll reveal answers. All right, here we go. Oops. Here's how we're going to do VW. Take the 2 points, -8 plus 4, or plus -4. They add up to -12 divided by 2. Midpoint of that guy right there at -6. Okay, continuing with the rest of them, same kind of thinking. For Vy, it's -8 and 3. Add them up, divide by 2, and continuing on. Okay, hope you got them all. Now, when you go to the coordinate plane, and of course the coordinate plane is our xy axes crossing in the middle like we have right here. Okay, when we go to the coordinate plane as opposed to the number line, now we're going to use the same idea, but we're going to take the mean of both the x coordinates and the y coordinates, and we make it look like this. Okay, here's our formula, and what it means is that the x and y coordinates of the midpoint, while the x coordinate is the average of the x values, y coordinate is the average of the y values of the two endpoints. Everything clear there? We'll make it clear, I hope, in just a second if that's not clear to you, okay? Average the x's, we'll get the x coordinate of the midpoint. Average the y's, we'll get the y coordinate of the midpoint. So, for this particular line here, A is at -4.7, B is at 8.3. Using this formula, we take the average of the x coordinates, the -4 and the 8, and we plug them in right here, divide by 2, and we find the x coordinate of the midpoint is 2. Same thing is going to happen with the y coordinates. Y coordinates are 7 and 3. Add them up, divide by 2, we get 5. Therefore, the midpoint is at 2, 5. And we've split our line, our segment, into two congruent halves. And that makes sense also. Check it out. We go down 2 and over, however many that is, 6. Down 2 over 6. We've created two congruent triangles. So therefore, these two segments here must be congruent. Cool? Cool. All right. Moving on. One to try on your own. Hit pause. And when you hit go again, here comes your answer. So the x coordinate at this point, 6 and 1, average them out, I get -2.5. Y coordinates, 4 and 10, -4 and 10, average them out, I get 3. So midpoint is at -2.5, 3. We got it. Okay, easy enough. Makes sense, I hope. Good. All right. Now, they're also going to give you problems where they're going to give you an endpoint and a midpoint and ask you to find the other endpoint. All right? So what we're going to do in a case like this is we're going to use the same formula, but we'll work it backwards. So the x-coordinate of B, of our unknown point, must be where the midpoint is the average of the -5 from here and the x that's unknown from here. All right? So multiplying both sides by 2, we get 6 equals -5 plus x. And then adding 5 to both sides, we get 11 equals x. All right, same thing with the y coordinate. It must be where 2 equals -4 plus y over 2. Multiply both sides by 2. 4 equals -4 plus y. Add the 4 to both sides. 8 equals y. All right, so B must be at 11.8, somewhere right up here. We have point B. Okay, Hope that made sense, because now's one for you to try on your own. A's at 1.7, midpoint's at -3.3. Where is B? Hit pause, try it, and then hit go. And hopefully you find out what's written here. I'll let you pause and go through it if you need to, but you'll find out hopefully that B is at -7, -1. Make it green. -7, -1. There's B. Cool, cool. Finally, distance formula. All right, distance in a coordinate plane. Kind of a complicated explanation, but we're going to go back to the Pythagorean theorem, which I'm hoping you're all familiar with. It says a squared plus b squared equals c squared, where c is the length of the hypotenuse. Well, what we'll do in a case like this is picture our segment as the hypotenuse of a triangle. So I've roughed in red the rest of the triangle. Using the number line model that we started with, the absolute value of the difference of the endpoints, okay, we know that xz must be, again, order doesn't matter on this since we're taking the absolute value. I went 7 minus -5, or 12 for that length right there. Next, I did the same thing for the y dimension here, which is 5 minus -4, or 9. Cool? So, what we got is 12 and 9 for A and B on our right triangle, right? So I plug it into the Pythagorean theorem. 12 squared plus 9 squared must be xy squared. Or 144 plus 81, or 225. And when we take the square root of both sides, we find the distance between x and y must be 15. Okay, now long ago, some smart person did all that we just did using the same logic, but simplified it into one little formula right here, the distance formula. And that looks like this. D is the square root of the difference in the x value squared plus the difference in the y value squared. And you will want to memorize this. So, using our same line, we just plug in the same values. 7 minus -5 squared, 5 minus -4 squared, 12 squared plus 9 squared, 144.81, etc., and get the same result, just taking what we did back a page and doing it using the distance formula. Same thing, just simplified into one formula. Okay? So, you get to try. Hit pause. Hit go when you're ready. What you find out, 6 minus -4 gives me my difference in my x values. Oh, don't want to do that. Gives the difference in the x values, or it gives you the line right here. And 7 minus -8 gives you the distance from here. 10 squared plus 15 squared, 100 plus 225, 325. Take the square root. You find out our distance here, 18.03. Cool? Cool. So, we're done. Hope that gives you a try. If you need to watch it again, of course, you are welcome to do that. Hopefully it makes sense and you're able to do the homework. See you tomorrow.